Now, let us try to prove this statement. It is a necessary and sufficient condition. If delta is negative, this condition is to be fulfilled. If this is done, delta should be negative. There are the two parts in this particular theorem. Say we can go to first part. Suppose ax square plus bx plus c by a, we know that it can be written as x plus b by 2a whole square plus 4ac minus b square by 4a square. Now, suppose delta is negative. If delta is negative, b square minus 4ac negative, so 4ac minus b square positive, positive by positive, this expression is always positive. Whereas, this expression when x is minus b by 2a is 0, in all the other cases it is positive. So, therefore, for all x belongs to R, 0 plus positive or positive plus positive is always positive. So, we can say that this expression is positive and hence ax square plus bx plus c and a will have same sign, will have same sign, will have same sign. Now, conversely, let us suppose that these two have same sign for all x belongs to R. In that case, by that relation, x plus b by 2a whole square plus 4ac minus b square by 4a square is always positive. Now, for all x belongs to R, it is positive. We know that it can be 0 or positive for all x belongs to R. 4a square is positive. If 4ac minus b square is definitely positive, then only the result will be positive. Even if it is 0, there is a possibility of getting 0, but we have to get positive. Therefore, 4ac minus b square must be positive and hence b square minus 4ac negative, that is delta is negative, and hence for a given quadratic expression, if delta is negative, this expression value and a will have same sign for all x belongs to R. That is the result. You see this particular statement, a, b, c are real numbers such that a not equal to 0. Ax square plus bx plus c equal to 0 is such a quadratic equation which has real and equal roots. That means delta equal to 0. In such a case, the conclusion is ax square plus bx plus c expression and a will have same sign for all x belongs to R except one case, when x is equal to minus b by 2a. Except when x is equal to minus b by 2a, or else otherwise these two will have same sign. Let us prove it. Consider ax square plus bx plus c by a. We know that it is x plus b by 2a whole square plus 4ac minus b square by 4a square. When x is equal to minus b by 2a, this expression will be 0. So, the value is going to be 4ac minus b square by 4a, that is, and this value ax square plus bx plus c by a will be equal to 4ac minus b square by 4a. Now, suppose if delta is 0 for the given equation, this is 0 by 4a square will become 0. When x is other than minus b by 2a, this particular expression is always positive and this is going to be 0 which is positive, and hence we can say that ax square plus bx plus c by a is always positive for all x belongs to R except minus b by 2a. That is, these two expressions, especially when x is minus b by 2a, this expression's value becomes 0. For all the other values, these two will have same sign. That is, if a is positive, the expression is entirely positive. If a is negative, the expression is always negative. That is the meaning of this statement. Now, you see this statement, if a, b, c are real numbers and a not equal to 0, such that the quadratic equation ax square plus bx plus c equal to 0 has real roots, that means delta positive, say alpha beta, with alpha less than beta. Out of those two roots, because real and distinct roots, alpha is less than beta case, then for all the values between alpha and beta, this expression and a will have opposite sign, and for all the values of x which are less than alpha and greater than beta, this expression and a will have same sign. Let us see. So, the expression ax square plus bx plus c can be written like a into x minus alpha into x minus beta, because in this case the equation has two real roots where alpha less than beta. Now, we can write like ax square plus bx plus c by a is x minus alpha into x minus beta. Like you can just imagine x minus 2 into x minus 5. Now, you take the real line, plot 2, 5. You take any x value between 2 and 5, x minus 2 is negative and x minus 5, between 2 and 5 if you take a number like between 2 and 2, x minus 2 will be positive, x minus 5 will be negative, positive into negative is going to be negative. So, statement 1 you see, for any x you take between alpha and beta, x minus alpha positive, x minus beta negative, the product will be negative. So, this will be less than 0, that means these two will have opposite sign. For any x, I am trying to prove statement 2, for any x more than 5, here I got negative, for any x more than 5, x minus 2 positive, x minus 5 positive, positive into positive is positive. Same logic, for any x more than alpha, this is positive, this is positive, the product is positive, and hence these two will have same sign. Even for any x less than 2 here also positive, because you take any x here, for that x, x minus 2 negative, x minus 5 negative, so product will be positive. So, same case here, for any x greater than beta or less than alpha, you see for less than alpha, x minus alpha negative, x minus beta negative, the product will be positive. When the product is positive, we say that these two will have same sign. That way we can prove the above statement. Now, let us see various cases of graphs of a quadratic expression ax square plus bx plus c. Before that, let us recollect 2 points, that is, for ax square plus bx plus c, if a is positive, the graph will be an upper parabola. If a is negative, it will be a down parabola. The next, if for a quadratic expression, suppose delta is positive, it is going to 0 2 times, that means it is going to have 2 real roots. So, it has to cut x axis at 2 points. If delta is 0, it must have real and equal roots, that means it will touch x axis only once, it will be like this. And if delta is negative, it should not have real roots, that means it should not cut x axis. 3 points, let me repeat. If delta is positive, graph has to cut x axis at 2 points, delta 0, it has to touch at 1 point, delta negative, it should not cut x axis because it has no real roots. Now, coming back to the point, You see, this is a structure, the graph of ax square plus bx plus c, a positive case upper parabola, a negative case down parabola, delta positive, delta 0, delta negative. Now you see, suppose this is x axis, a positive upper parabola, delta positive, it has to cut x axis at 2 points, this is the curve, and a negative means down parabola, it has to cut x axis at 2 points, so it will be this curve, because down parabola has to cut x axis at 2 points. And coming to delta equal to 0, a positive upper parabola has to touch x axis at 1 point, this is the case, and here a negative down parabola has to touch x axis at only 1 point, this will be the position of the curve. Now a positive and delta negative, no real roots, it will be completely above x axis, and a negative here, that means no real roots, and down parabola it cannot be like this, it must be completely below x axis. So these are the 6 positions of the graphs. Now we can understand the previous 3 statements also. Here when delta is negative, for all x from minus infinity to infinity, quadratic expression is negative. So quadratic expression and a have same sign. Similarly here when delta is 0, at this number minus b by 2a, this expression's value becomes 0, at all the other values it is positive here because a is positive, it is negative here as a is negative. Whereas here you see, in this case if it has 2 roots alpha comma beta, for all the values of x less than alpha and greater than beta, positive, which is the sign of a, between alpha and beta, negative, which is opposite sign of a. In this case for all this is alpha, this is beta. Here also for less than alpha and greater than beta, negative, which is sign of a, between alpha and beta, positive, which is opposite sign of a. So the meaning of the previous 3 results is clearly be understood here in this curve. So far we discussed about quadratic equation and we were discussing about quadratic expression. In the last class we have seen, for the quadratic expression ax square plus bx plus c, when a is positive, the graph will be an upper parabola, it will have minimum value 4ac minus b square by 4a when x is equal to minus b by 2a. In the same way, when x square coefficient a is negative, the graph will be a down parabola and it will have maximum value 4ac minus b square by 4a when x is equal to minus b by 2a. Right. Now let us see some problems based on this. Let us see this problem. Find the value of x at which the following expressions have maximum or minimum. You see, one expression is x square plus 5x plus 6, whereas other expression is 2x minus x square plus 7. Let us first do this problem. You see, this expression is a quadratic expression. Compare this with ax square plus bx plus c. Here a is 1, b is 5 and c is equal to 6. Now observe a, is it positive or negative? A is 1, which is positive. If a is positive, the curve is going to be upper parabola. It will have local minimum when x is equal to minus b by 2a. It will have minimum when x is minus b by 2a, that is minus b is 5 by 2a is 2. That means when x is minus 5 by 2, this expression is going to have minimum value. Even with the help of calculus also you can do, you know that when the first derivative equal to 0 and second derivative, by observing second derivative we can talk about its minimum maximum. You see, take the derivative of this expression, this is 2x plus 5 equal to 0. So, x is minus 5 by 2, whereas the second derivative is going to become 2. As second derivative at this number is positive, it will have local minimum when x is minus 5 by 2. So, this question can be answered with the help of algebra by using x is minus 5 by 2, or even with the help of calculus when first derivative is 0 and second derivative positive. So, it will have minimum value at x is equal to minus 5 by 2. Likewise, you come to this problem. This is a quadratic expression where a is minus 1, b is 2, c is 7. Since a is a negative quantity, the graph will be a down parabola and it will have local maximum. So, local maximum value is possible. Maximum takes at x is equal to minus b by 2a, that is minus 2 by 2 into minus 1, which is equal to 1. That is, when x is equal to 1, it will have local maximum. Even the same can be done with the help of calculus. Take the first derivative of this expression, which is f dash x is going to be 2 minus 2x, and first derivative is 0, implies you will get x is equal to 1. Moreover, second derivative is going to be minus 2. Even at x is equal to 1, it is negative. So, at x is equal to 1, first derivative is 0 and second derivative is negative. So, it will have local maximum, and hence the answer for this question is when x is equal to 1, it is going to have local maximum. Now, you see this problem. Find the maximum or minimum value of the following quadratic expressions. There are two expressions given. First, you see this expression 3x square plus 2x plus 11 is the expression. First, you try to compare this with ax square plus bx plus c. Here a is 3, b is 2 and c is 11. Now, as a is equal to 3 is positive, the parabola will be upper parabola and it will have local minimum. And we know that the minimum value of a quadratic expression is going to be, in this case, 4ac minus b square by 4a, which is 4 into a is 3, c is 11 minus b square is 4 by 4a, 4a is 3. You can take 4 common and cancel. 33 minus 1 by 3, which is 32 by 3 is going to be its minimum value. In the same way, come to this expression. Here also it is a quadratic expression where a is minus 5, b is 2, c is minus 7. In this case, we can say that as x square coefficient a is negative, the parabola will be a down parabola and it will have maximum value, and that value is 4ac minus b square by 4a, and hence we can say the maximum value of the quadratic expression is 4ac minus b square by 4a, which is 4 into minus 5 into minus 7 minus 4 by 4a, 4 into minus 5, which if you cancel 4, 35 minus 1 by minus 5, which is minus 34 by 5 is going to be its maximum value.